Welcome back to another AI Practitioner Exam Bite, reviewing the question from the previous episode, asking us which statement is a fair assessment of the performance of the spam filter. The answer is D. The filter balances well between catching spam and avoiding misclassification of legitimate emails. It caught 1,800 out of 2,000 spam emails, which is 90% of all spam, so it's good at catching spam. It incorrectly marked 300 legitimate emails as spam out of 8,000 legitimate emails, which means it correctly identified 96.25% of legitimate emails. So it's good at avoiding false positives. And the F1 score balances these two aspects. A score of 0.85 is generally considered good, especially in a real-world scenario with an imbalanced data set, more legitimate emails than spam. All right, today is an exciting day as we're going to start on our brand new domain, which is domain 2, Fundamentals of Generative AI, and task statement 2.1, explain the basic concepts of generative AI. Let's start with the basics and the exam objective. Understand foundational generative AI concepts, for example, tokens, chunking, embeddings, vectors, prompt engineering, transformer-based LLMs, foundation models, multimodal models, and diffusion models. All right, that's a lot of terminology, so buckle up because we've got a lot to cover in just a few minutes. Starting with foundation models, or FMs. These are large pre-trained models that serve as the base for various tasks. They're trained on vast amounts of data and can be adapted for specific purposes. One type of foundation model are large language models, or LLMs. These are AI models trained on vast amounts of text data and can parse, generate, and manipulate human-like text. LLMs form the basis of many modern AI applications, from chatbots to content generation. The transformer architecture is a particular type of neural network architecture which excels at processing text-based data. Many modern LLMs are built on a transformer architecture, enhancing their capability to understand context and generate coherent and relevant text. So we have our LLM, but how do we provide it with input? Well, that's done through a prompt, the initial input given to an AI model to generate a response. The prompt could be a question, a statement, or a set of instructions. The art of crafting effective prompts to get the desired outputs from an AI model is known as prompt engineering. It involves strategically designing prompts to guide the AI in producing relevant and accurate responses. Skilled prompt engineering can significantly improve the quality and usefulness of AI-generated content. Now let's say your carefully crafted prompt is actually quite large, perhaps because you've included an entire document in the prompt which you want summarized by the large language model. Well, the model doesn't have infinite memory, and that amount of text might not fit into the AI's memory. So it needs to be chunked, which means breaking down a large piece of text into smaller, more manageable pieces, which can be individually fed into the model separately. Now, we might not need to chunk the text. It might be small enough to fit into the AI model's memory. In fact, most modern models have a pretty big memory, so you probably won't need to do this unless the prompt is massive. But regardless of whether we chunk the text or not, once it's fed into the AI model, the text is tokenized, which breaks the text into smaller units called tokens. Tokens are the building blocks of text in AI models. The tokens are then converted into embeddings, which is a numerical representation of that token. AI models can't understand text. They can only understand numbers. So they need some way to represent text numerically, and that's what embeddings do. They're actually stored as vectors, which are a list of numbers to represent data. But embeddings are just not any type of vector. Vector embeddings, which are numerically close to each other, are semantically similar in meaning. So this is pretty cool. It allows us to numerically represent words which are similar to each other because they're numerically close to each other. So far, we've just been talking about text-based models, but there are other types of models which fall under the category of multimodal models. That's a bit of a tongue twister, isn't it? Multimodal models. These models can process and generate multiple types of data. For example, they might work with both text and images. One example are diffusion models, which are a class of generative model used primarily for image generation. They work by gradually adding and then removing noise from data to produce an image. These also work with text, as you generally provide a text-based prompt and they'll generate an image which follows that prompt. Whew, that's a lot of terminology. Let's do a review question to finish off. Which of the following best describes the relationship between prompts and prompt engineering in generative AI? A, prompts are the algorithms used by AI models, while prompt engineering is the process of creating new AI algorithms. B, prompts are the outputs generated by AI models, while prompt engineering is the process of interpreting these outputs. C, prompts are the training datasets for AI models, while prompt engineering is the process of collecting and curating these datasets. Or D, prompts are the initial inputs given to AI models, while prompt engineering is the art of crafting effective prompts to guide the model's output. As always, post your answer into the comments, and I'll see you in the next episode where we'll answer this question and look at the foundation model lifecycle in more detail.